Welcome to the new topic, that is Bayesian classification. Myself Priyanka Gupta. I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So today I will cover about the Naive Bayes theorem. Then we will discuss about how it is going to work. We will take a case study of whether there will be the player, whether he is going to play or not. For that, we will take the classifier and we'll see the results. And then we will see the advantages and disadvantages of naive-based classifier. Then we will see the how many types of classifiers are there, naive-based classifiers are there, and we will see how to improve the power of naive-based classifier, naive-based model. So what are the different remedies are there? We will see about that. Naive-Bayes theorem. So basically it is a classification technique or method that is based on the Bayes theorem. Bayes theorem is nothing but that is a probability based rules, so that we have seen in last session. So that is a classification technique that is based on the Bayes theorem and with an assumption of independence among the predictors. So we have to predict about the unknown classifiers here. So in simple terms, we can say the naive-based classifier that assumes that if the presence of a particular event is there, if particular feature is there for the class, so that is unrelated to the presence of another feature of the same class. So that basically is nothing but that is by the classifier, the classifier is assuming that the presence of a one particular feature that will be unrelated to the other feature from the same class. So for example, if we'll take an example of fruits, a fruit is there, so that is having the sum of the properties, that is red, that is rounded, that is about 3 inch in the diameter. So if 3 of the property are there, so if that particular fruit is apple or not, so we have to classify, we have to check these of the property on the behalf of classification, and then that will go into the class of apple. If it is apple, it will go into the yes. If it is not, then it will go into the no. So some of the fruits that will look like that have the same property, but that will not the apple. So on the basis of some of the properties, we have the classifier is going to classify the same fruit. If it is same fruit, the apple or not. So even if these features what we have seen, that will depend on each other. So we can say that that will depend upon the existence of each other features. So all of these properties independently contribute to the probability. So that is nothing but there will be the occurrence of probability. There will have some probability. So on the basis of that, this fruit, the particular fruit is an apple, and why it is known as naive. So that is the naive classifier. So we know the properties, but we don't know that is an apple fruit. So that's why we are telling this particular algorithm as a naive. Bayes comes from the Bayes theorem, basically. Right. So that was the what is naive and what is Bayes. So and what are the properties are there, on the basis of that we have to classify, the classifier have to classify the same fruit. So naive-based model is easy to build particularly, and that is very useful for very large, while we are having very large data sets, while we are having large databases. So for that we can use the same classifier. So for the particular problem, if they are having some type of property that is a dependency of one event, that is we have to identify the particular other activity. So on that we have to take the naive Bayes classifier. So Bayes theorem basically provides the post-error probability. So that is nothing but the P A given B. So that is nothing but this is the post-error probability. So that is nothing but the conditional probability, because one condition is depending on the other condition. That one event is depending on the other event, that is B, and first event A. So here we the P of A given B have to calculate in the terms of what we have what we should know about that. So in the formula of the Bayes theorem, that is the PB given A into PA divided by PB. So that is the other event, that is the first event. So that will be calculated from the same formula of the that is posterior probability of the same model. So where the PA given B is the posterior probability of class A. So if some event is there, if some class is there, that is A, and other that is having the target, that is actually having the target, what target we have to achieve. So that class is nothing but that class is A class. That is A class. So that will be the target, and the given predictor is nothing but P of B was written there over there. So P of B, so B is having the attributes also. So P of B, that is having the given predictor, that is having the P and attributes. Again P of A, so that is nothing but the probability of A, that is the class prior probability. And the other term was missing, that is P B given A. So that is nothing but the likelihood of the same. So again here P of B, that is nothing but the predictor prior probability. So because that on the basis of this predictor prior probability, we are going to know about the posterior probability. So that is nothing but the evidence, that if this evidence will be there, then only we will able to we will be able to check about the PA given B. So B, that is the evidence. So how this NF Bayes algorithm is going to work in real time. So here we have taken a training data set. An example is there. So in this training data set, that is a weather data set, that is based on the weather. So in weather, if we will see in the example, if we'll see in the table of this weather data set, so here in the left hand side, the one table is there, that is having the weather, and the that is another class level, that is having the play. So weather types are there, some of the types are there, sunny, overcast and rainy, and the classes are there, that is the class level is play, that the classes are there S and no. These are the classes. So we have to classify the classes. If same weather will be there, so there will be the player if he is going to play or not for these of the few weathers. So on the basis of that, the new classifier will work. So the corresponding table, the target variable is play. So here the suggesting possibility of playing. So if there is a possibility the player is going to play or not outside. So now we will need to classify them, whether the player will play or not based on the weather condition. So now after this table, the first table is given. On the basis of that, we have to make a frequency table after that. So the frequency table is nothing but we have to see what is the occurrence of that same frequency, in the same play class levels. How many frequencies is there? In the overcast weather, in the rainy weather, and in the sunny weather. So here we will see, if we'll see in this example, the weather that is having the class level NO and S. So that is having three types of weathers are there: overcast, sunny, and rainy. So overcast, how many times S is there? 4 times. So if we will check the 4 times in the overcast, so yes, this 1, this 2, this 3, and this is 4. So 4 times, that is there is S and no nothing, that is 0. So like this we have to make a frequency table, and we have to do the grand total of that same S and no class level. So S is if S is there, so 9 grand total is 9. If no is there, grand total is 5. So like that we have to make the frequency table in the some steps, other steps. In the other step, we have to make the likelihood table. That is nothing but on the basis of this frequency table, we have to know about the particular classifiers. What is the probability of the same classifier, same likelihood. So for overcast, we have to calculate that if S is there, so 4 divided by 14. 14 is the total of the two of the events. If S is there and no is there, so 5 plus 9 is equal to 14. So that will be divided by 14, 4 by 14, that is 0.29 is the probability of that overcast weather. If weather is overcast, then 0.29 probability is there if player is going to play or not. So for rainy, like that same, we have to do the total of this S and no. How many frequency were there? So here 0 were there, so that was 0 plus 4 was 4. So here 5 divided by 14. Like same, sunny will be there, 5 divided by 14. So we have got the 0.29, 0.36 and 0.36 for the overcast, sunny and rainy season. Now we will see the steps, the particular steps. That was the only I have told about the what is there in this table of the player table, weather table. So now some steps to do classification, what I have told in this earlier slide. So in step 1, what we have to do, we have to convert the data set. The data set were given in the form of, there were weather type and the class levels were play if the player is going to play yes and no. Those were the two classes, binary classes were there. So that same data set we have to convert into the frequency table. So that will be the first step while we are going to do the naive Bayes classification. Next, the step second will be there. In the next step, we have to create the likelihood table. We have to create the likelihood table. So likelihood table will be there. We have to find out the probability, that is the overcast probability. So that was the weather type overcast. So for that, the probability we got that 0 plus 4 divided by 14, that comes as a 0.29. So the probability is 0.29. And probability of playing will be minus from the 1. So that is nothing but the P is equal to 1 minus P. So if we will minus the P from the 0.29, so that will come as a 0.64. So that is a probability the player is going to play outside in the overcast weather. So like this, we have to calculate the other for the other types of weathers. So that was for the overcast, and that was for sunny. That was 5 divided 14. That was a 0.36. So we will minus the 1 from the 0.3 from the 1. That will come as a 4, and that is 60. So like this, we will have got the result if the player is going to play or not. So that was that we will get. We have to make that likelihood table, and we have to put these of the values, probability values for the other types of weathers, like this. So now in the third step, we have to do the naive Bayes equation. So there were the naive Bayes equation, that was P A given B. So that we have to calculate that equation. So for that, each of the classes. So 2 of the classes are there, yes and no. So for that, we have to calculate that post-error probability, that is A given B. So the class with the highest post-error probability, that will be the outcome of prediction. So the highest probability will be there. So the chances is there. So the player is going to play outside in that same weather. So that will be the highest post-error probability. So here the same case study is there. So what data set we were having, that were the 3 types of weathers were there: overcast, sunny and rainy, right? So in there, the 2 of the class levels were there, yes and no, in the play. So that play was the class level, in that the 2 classes are there, yes and no. So the problem is player will play if weather is sunny, is this statement is correct or not. So we have to check this statement. So we will solve it using the post-error probability. So post-error probability formula is there, that is having the P A given B is equal to P B given A into P A divided by P B. So that is the first and second event. So if we have to calculate the P S given Sunny, so if S if class is S and weather is sunny, so why if the player is going to play or not, what is the probability? So we will calculate the post-error of that. So that will be the, from formula we will get P sunny given S into PS divided by P sunny. So that will be the formula for that. So P like that we have to calculate the P sunny given S. So P sunny given S will be the 3. For that we have to calculate this I think. So this we have to calculate, so that will come as a 3 divided by 9. So how many times sunny is appearing for if weather is, if the yes is there. So that calculation will be the 3 and divided by total is 9. So the probability it comes as a 0.33, right? So from that same table. From that same table. So now we will calculate the probability of sunny. So probability of sunny is that 5 divided by 14. So 14 is nothing but that total of S and no event. So here we will take the whole of the event. So that will be the 5 divided by 14, that will be the 0.36. Now we will consider the probability of S. How many times S is occurring? So what is the probability? So that will be the 9 times it is occurring and total events are S and no 14. So that will be the 0.64. So now we have to put these of the values in this same formula, that in that we are going to calculate the PS given sunny. So that will be the PS sunny given that the 0.33 into PS is 0.64, that is divided by P probability of sunny, that is 0.36. So that we will multiply and divided by 0.36. That will be the post-error probability of the PS given sunny. So now S given sunny is equal to that came as a, if we will calculate these of the from that formula 0.33 into 0.64 divided by 0.36, so that will come as a 0.60. So that is nothing but that is having the higher probability. So for here we have taken the S sunny. So like this we have to calculate for S overcast is there, S rain is there. So that from that we have got the less, we will get the less of the probability. So the 0.6 is having the higher of the probability other than those overcast and rain. So if weather will be sunny, then player is going to play the game outside. So he definitely is going to play, because the probability rate is more than 50%. So there is a chances, but not that strong chance. But whether we are going to say the player is going to play some game in the sunny weather outside. So the naive Bayes uses a similar method to predict the probability of different class based on the similar various attributes. So naive Bayes is nothing but that is going to similar method, and that is going to predict about the probability of different class based on the various attributes are there. So that are nothing but these are having the class, in the class they are having the attributes. So this algorithm is mostly used in the text classification. So if text classification will be there, like we were having the S and no, so these type of applications will be there, these types of models will be there, then we are going to apply the name-based classifier. So that will be that is mostly used by this particular algorithm, and with the problems having the multiple class. So that was the actually multiple class. In the text classification also we can use the name-based classifier. So what are the advantages of to use the name-based classifier? So first is it is easy and fast to predict about the classes of test dataset. So that is fast because that is having the probability formulas, and directly we can use that numerical and categorical and text values. So on the basis of that we can we will be quick to identify what is the predicted class is there, class level are there, from which the particular problem has been solved. So it also perform well in the multi-class prediction. So the same name-based classification is particularly using in the multi-class prediction. So when assumption of independence holds a name-based classifier, that is going to perform better. That is particularly going to perform better compared to other models, because that is having the logistic regression, and you need to do the less training data. We need to have the less training data. So because of that, the name-based classifier is giving the particular better results rather than other models. So it is going to perform well in case of categorical input variables. If we are having the categorical input variables, that is having the categorical type of values, so compared to the numerical value, so for that numerical value normal distribution can be achieved. So bell curve will be there, which is having the strong assumption. So if normal distribution will be there, so that will be the strong assumption that the particular event is going to happen. So, but if we are having the categorical type of values, categorical type of variables, then we will use the name-based classifier. So it is the most popular and particular choice for to do the text classification for some of the problems. So that were the advantages of name-based classifiers. What are the disadvantages of name-based classifier? So if categorical value has a category, so while we are using this for the particular categorical values, categorical variables, so if we will have some class, some category for that in the test data set, so which was not absorbed, that is not having that is not in the training data set. If that is not occurring, that is not there in the training data set, so model will assign a 0. So if that will not get from there, if the test data will be checked from there, so that will give the 0. The result will be the 0. That is going to be 0 probability. That is not going to happen. So on this particular event, so we will be unable to make a prediction. So that will be the false for that same situation. So this is often known as a zero frequency. This is the zero frequency problem. So this type of problem we have to solve. How we can solve these of the problem? There were some smoothing techniques to resolve these of the problems in the larger data sets. If you are having the larger data sets, we have to apply some of the smoothing techniques. So to avoid the zero frequency. So to solve this, we can use the smoothing technique. One of the simplest smoothing technique is Laplace estimation. So one technique is we can use that in the same condition, that is Laplace estimation. On the other hand side, the other disadvantages is there. That is the name-based classifier, that is particularly called as a bad estimator. Why it is bad? So the probability outputs from the predicted probability are not to be taken too seriously. So some of the times we cannot take the some type of prediction seriously, because if it will give the 0, how we are going to rely that? So that type of probability we cannot take further. So for that, it is the bad estimator. Another limitation of this name-based classifier is that is the assumption of independent predictors. So in real life, it is almost it is impossible actually, so that we get a set of predictors which are completely independent. So for that is a limitation. We cannot predict about the set of predictors that are having the independent predictors. So this is also the disadvantages of the name-based classifier. Yes. Now, what are the different applications of name-based classifier? In which of the area real-time applications are there? We are going to use the name-based classifier. We are going to apply. So in the real-time prediction, if you are doing the real-time prediction, So name-based classifier is an eager learning classifier, and it is surely the fastest algorithm. That is the fastest classifier. So thus it could be used for the making predictions in the real time. So we can use the name-based classifier on that same problem. So multi-class prediction, if you are having the multi-class problem, this algorithm is also known as a multi-class prediction feature. So on that basis, here we can predict about the probability of a multiple class target variable. So for that we can use the name-based classifier. In the text classification, in the spam filtering, sentiment analysis, that is, we can use the same name-based classifier. So about what is spam filtering? So in our email system, so that we can get the spam will be there. So some of the mails that is going in the spam also. Some of the important mail also it is going into the spam. So for that we have to use the that is basically how it is working on. It is working on basically on name-based classifier. So on that we can use in the real time the name-based classifier is going to use. Sentiment analysis. So some of the particular sentiments will be the some of the literals will be there. Some of the if some text is there, from there we can retrieve these of the some sentiments from there. So we can do we can use the name-based classifier for that. So name-based classifier mostly that is used in the text classification, right? So that is basically the most like widely used problem is there. So on that we are using the name-based classifier. So that is due to better result in the multi-class prediction, and that is going to give the independence rule and having the higher success rate is if it is going to compare with the other type of algorithm, other type of models. So the particular name-based classifier it is going to use in the spam filtering, sentiment classification and text classification. As a result of it is widely going to be used, the spam filtering, that is identify the email, spam email is there or not. Sentiment analysis in the social media, if we will see that I have given the a small example of a particular document, but if we will see in the particular social media analysis, if you are going to do the social media analysis, so if we are going to take the if positive and negative customer reviews are there, customer sentiments are there, so they are writing some of the comments there over there while they are giving the while they are giving the ratings for some particular products. So for that we can identify what type of who are the users they are giving the how many users they are giving the positive rating and how many are giving the negative. So like that we can do the other type of classification also on the same for the sentiment analysis. So there we can use the name-based classifier basically. The recommendation system. For recommendation system, what is recommender? So basically the recommender is nothing but if we'll take a real-time example, there is the online website that is having the Amazon, Flipkart, so they are having the so many products over there. So if we will if we have purchased some of the product over there, so the some of the recommendation will be coming. Some of the like we can say pop-up will be coming. So you can also check this is the product similar to your product what you have bought from this website. So like that for that classification the name-based classifier it is going to be used. So name-based classifier and collaborative filtering together builds a recommendation system. So that uses the machine learning and data mining algorithms to filter the unseen information that we cannot see, and that is going to be in backend, and that is going to be predict about a user would like a particular resource, a particular product, he is not going to like the same product. So like these are the recommendation system, the name-based classifier it is going to be used on the basis of some of the possibilities there will be the some machine learning algorithm and data mining algorithm. Now we will see how many types of name-based classifiers are there. So there are particular 3 types of name-based classifiers are there. First is Gaussian, second is multinomial, and third is Bernoulli. So these are the three types of naive Bayes classifiers are there that are present. So multinomial naive Bayes classifier, that is mostly used for document classification problem. So if this type of problems will be there, whether a documents belong to the category of sports, politics, or technology. So if there is a suppose there is a newspaper, there is an online newspaper. So if that same newspaper has to be verified, if the same page, the page number this is particular having the sports, that is not having the politics, and that is not having the technology type of news over there. So like this type of classification, we can use the multimonial naive Bayes classifier. So here in this type of classification, the feature vector that is going to be present, that represent the frequency with which certain events have been classified and generated by the multinomial distribution. So basically it works on the basis of feature vector will be there. So what is feature vector? That is nothing but that is basically in mathematics term, that is a vector. On the basis of that, the frequency will be that will be counted. So for that is going to represent the frequency for the certain events that is having the multinomial distribution. So this is the event model typically used for the document classification. Second is Bernoulli naive Bayes classification. So in this classifier, this is similar to the multinomial naive Bayes classifier basically, but that is going to predict about the Boolean variable. So that there were non-Boolean variables. Here we will classify the variables into the Boolean type. So the parameter that we use to predict about the class variables take up only two of the values, S and no. So if there is a sum of type of data that is having the yes and no types of variables, class variables, so we are going to use the Bernoulli naive Bayes classifier. For example, if a word is going to be there in some of the paragraph that is not having in that particular paragraph. So these type of classification we will use the Bernoulli naive Bayes classifier. So if in the multivariate Bernoulli event model, that is going to feature are independent Booleans. So if the multivariate type of model will be there, so that is having to use the independent Booleans, that is having the binary variables that is going to describe the input. So like the multinomial model, this model is also popular for the document classification. So if we are having the document classification problem, we can also use the multinomial, but it is used for the only two of the classes. If whether it is having the two of the classes S and O, and some of the classes like that will depend on the other. That will depend on the each other. So whether the binary terms occurrence, if the word is there in the document or not. So this is the dependency. One event is whether the word is there in that particular document or paragraph or not. So that is the binary type of classification. So there we will use the Bernoulli naive Bayes classifier. So rather than the frequency, if there is a frequency of word, the word is there or not, so we will not use that Bernoulli naive Bayes classifier. So when it is going to plot the Bernoulli naive Bayes classifier, it is going to give the this type of bell-shaped curve. So in this bell-shaped curve, that is actually having this is the Gaussian classification actually. So in this classification, there will be some point that from there the bell is the shape is going to be start, and there it is going to be stopped. So there will be the tail of that. So that is having the bell tail and bell upper tail and lower tail. So in between, when it is going to make a curve that is having the bell shaped shape. So this will be the mean of. So these are nothing but these are the data points. These are the data points plotted over there. That is going to make this Gaussian that is the bell-shaped curve. So here there somewhere that will be there will be the mean of that. That is nothing but in the this side, that is the density of that particular event. So the likelihood of features that is going to assume that is Gaussian. So on the basis of that, we will calculate the conditional probability. So what is the formula of that? So P of x, that is equal to 1 divided by under root 2 pi sigma square e to the power minus x minus mu of whole square divided by 2 mu whole square. So here the mu is nothing but that is mean of that. So from this particular formula, we can calculate the conditional probability for the likelihood of the features. So now when what if any feature contains the numerical value? If there will be the numerical value, we are going to use the Gaussian distribution. So for that particular categories, we are going to use the Gaussian distribution. So how we can improve the power of the naive Bayes system model? If there will be the model, how we can improve the power of that? So if the continuous feature do not have any type of normal distribution, so if we have used some of two types of models were there, three types of models. If we have used that, the plotting is there, so that is not having the normal distribution. So we should use the transformation. So if the dataset have not been the normally distribution, that is having some of the irregular and some of the other types of variance will be there. So we are going to use the transformation or different type of methods to convert it in the normal distribution. So that will so that is also drawback of that. We have to again we have to convert that particular distribution into the normal distribution. So second is, if test data is having the zero frequency issue, that is the problem we have seen. So we have to apply the Laplace estimation, Laplace correction. So that is the particular smoothing technique to predict about the class of test data set. So for that class level, we are going to predict. So for that, we have to apply Laplace correction, so the zero will not occur then. In the third problem, we have to remove a correlated feature. If there is a relevancy in the some of the features or variables, as that is highly correlated, that some we can say relationship is there, they are correlated, they are very similar. So we have to vote it twice in the model. We have to vote on that. If the particular, it can lead to the overflatting importance. So firstly, what is having the high voting? So for that feature, we have to go with that particular feature. So that is also a drawback. We have to improve that drawback from the naive Bayes model. Now, the naive-based classifier, that is having the limited options. For parameter tuning. So if suppose an example is there, alpha is equal to 1. So if we'll apply the smoothing technique, some of the smoothing techniques. So I am just formally telling about the problems of the naive Bayes classification. So I'll not go into the smoothing part. So if there will be the smoothing, so the problem will be there, alpha is equal to 1, and fit priori is equal to true given false. So to learn that class prior probability or not and some other options, we have to check. So we have to focus on the pre-processing. We have not go into the deep of that. We only have to, what we have to do, pre-processing of that data, because that is not is for our use. We have to re-smooth that. We have to reform that. The data will reform that. Then it is going to be used for a classification, and then we have to select some of the features from that. So for these type of limited options, we don't have to go for the smoothing technique. We have to do the pre-processing, and we have to normalize that, and then we have to take the sum of the feature. Then only we have to go for the classification of naive Bayes. So we can think about to apply some of the classification combination techniques. So here we can also think about, we can apply some of the combinations of the some classifiers, because there are some other classifiers are also there in classification, that are ensembling, bagging, and boosting. So we will go into that in later classes. But if we want to do some of the combination classification, we cannot do. Why? Actually, ensembling, boosting, and bagging, that wouldn't help, since their purpose is to reduce the variance. So we cannot reduce the variance while using these three types of classification. So naive Bayes has no variance to minimize. So that is a drawback of the naive Bayes. We cannot reduce the variance. If variance is there, if some of the we can say data set is not properly variated, so we cannot do the variation on that classifier. So that was all about the naive Bayes classifier, how we are going to use the classifier, what type of problems will be there. On that, we are going to do the naive Bayes classifier, naive Bayes classification. Particularly, that will be go for the text verification. So text documentation will be there, then only we are going to use the classification by the naive Bayes. If there will be the possibility, if spam filtering will be there, so multi-class type of classification, that will go into the naive Bayes classifier. Although we have seen the advantages and disadvantages of this same particular classifier, and how we can read off what are the different improvement of there, what are the different techniques we can use if there is some we can say problems are there, so we can also rectify that. So we have seen those of the problems also. So that was all about the today's class. We'll meet in next class. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.